Hello, today we're going to learn about quadratic formula, which you may have learned about in Algebra 1. The formula is on your formula sheet, which will be linked in the Google Classroom. And if you have been attending class in person, you'll have your own copy of this. The quadratic formula reads x equals -1 times b plus or minus the square root of b squared minus 4ac all over 2a. When these are touching, they're timesing. And when these are touching, they're timesing. Same with this. And this b squared over here is whatever b is raised to the second power. So please have that formula handy. These are very similar to solving by factoring for the very first step. So the first step is to make sure they're always set equal to 0, because once again, we're solving for the roots of a quadratic equation. So when we're solving for the roots, we want to make sure it's equal to 0, because that means the y value is 0, which would make it an x-intercept. You may be tempted to factor this one. It would be a little bit on the tricky side to factor, and some of these are not factorable. So what that means is there would be no numbers that would work out for your big X. So it's a little bit easier to use the quadratic formula. So if it's set equal to 0, we go in and we label our expression ABC. This is also on your formula sheet right here. So all of these should be in standard form, with A being the coefficient of x squared, B being the coefficient of x, and C being the constant. We're going to take just these numbers, not the letters. You can even highlight them if that helps. And we're going to plug those numbers into the quadratic formula. So it's x equals -1 times b, which is -7, plus or minus the square root of b squared in parentheses minus 4 times a, it's -5, times c, which is 90. And it's all over 2 times a, which you can do that step in your head if you prefer. So this is kind of how we plug in those pieces into our equation. And for sometimes you'll need a little extra paper for these, depending how big you write and how you do your problem. So you can do this little section using PEMDAS, order of operations, parentheses, exponents, multiplication, division, addition, subtraction. Or you can plug that whole thing in your calculator. So the first way I usually teach people to do it is to do all these steps at the same time, one by one in your calculator. And then I can show how to do that using PEMDAS. So -1 times 7, -1 times -7 is +7. 2 times -5 on the bottom is -10. And then this part we'll do in our calculator. So the way you can do this in your calculator is you do parentheses -7 squared. A little bit so there's not a glare. Minus 4 times -5. Parentheses 90. We're not including that square root sign. We're just putting in what's underneath the square root. Anything that's in parentheses, we use this little negative button. The squared is located right here by the x squared. Anything that's not in parentheses or not out front is a minus sign, not a negative. Good. It's going to be a really big number. 1849. So you could also do that part using PEMDAS. So I'm going to do that little part on a sticky. So you can either stop here and pause and wait for us, or you can try it out using PEMDAS and see if that makes it easier for you. So for PEMDAS, if you were doing this part in parentheses, we know -7 times -7 is +49. And then we would do -4 times -5 which is positive 20, and 20 times 90 is 1800, plus 49 is 1849. So if you're a PEMDAS person, please feel free to use it. You might just need a little extra paper. Now when we get to this step, all we have to do is take the square root of 1849. So we'll hit the second, this x squared button, and it'll give us the square root. It's 43. Most of these will have a square root, but if they don't, you can stop your answer right here. So what do I mean by if they don't have a square root? Technically, they all have a square root, but if this number turns out a decimal, you can stop your answer right here. If it doesn't turn out a decimal, you can keep going with it. We don't need the root anymore because we took the root. And now we're going to find our two final answers. And I like to draw two little arrows for this part. So to find your two final answers, on the top, you'll notice this little plus minus kind of wonky little sign. The top one, you'll do 7 plus 43, and you'll divide by negative 10. The bottom one, you'll do 7 minus 43, divided by negative 10. 7 plus 43 is 50. Over negative 10 is negative 5. That's our first answer. That's our first root where it crosses the x-axis. And then 7 minus 43, that's a tricky one. I might have to use my calculator for that one. Negative 36 divided by negative 10. That doesn't divide, so you could just leave it a fraction, make both of them positive, or you could do it in your calculator and see what decimal you get. But yeah, the two negatives can be crossed out. Decimals are just fine at the end. We just don't want decimals when we're doing the root. That is a 3, just looks a little weird. But when you're taking the square root of 1849, let's say that came out hypothetically a decimal, you would just stop your answer right here. Good. Most of these are going to have two roots. As we move into Unit 1B, we'll talk about what happens when a negative arises under the radical. But for all the ones we do today, there will not be a negative under the radical, which means that that graph, as long as you get a positive number under the radical, will hit the x-axis twice. So what does that look like on a graph? Let me just show you. So all of these, this graph doesn't align with this equation because it's negative, so it should go down, but this is just hypothetical. So most of these, if you get or all of these, if you get a positive under the radical, which you should for the most part, it'll have two real solutions, which we won't talk about imaginary until Unit 1B. Some of these graphs might just hit the x-axis and bounce right back up. And we call that one real solution. But you don't have to write that down right now, but that is something we're going to be learning about. When it has one real solution, that means you'll have only one answer here. That would be a situation where whatever's under the radical is just 0. So if you ever get a 0 under the radical, I don't want you to think you're wrong. That does happen sometimes, so just knowing that. So the key thing here is to just make sure they are set equal to 0 before you plug into this equation. So I want to do another one where it's not set equal to 0. So sometimes they do have like terms, like this one's nice. It has a like term, you can bring that over. Some of them don't. So when you're looking at a problem like number 3, this lovely problem does not have a like term. So when you bring that 30 over, it does become negative, so it'll cancel, but you have to carve out a space for it in order to make it A, B, C. We know that constant has to go at the back. So the 4 still goes first because it has a squared, so that's your A. Your 2n goes in the middle, that's your B. and your negative 30 goes at the end. That's your C. So when you're setting them up, just be really, really, really careful. I would hate for you to do all the work above and not have it set equal to 0 to start. So it'd be x equals -1 times b, which is 2. We're just plugging in the numbers. Even though that 2 is positive, I'm going to put it in parentheses just to be safe. B squared minus 4 times a times c. Some people will save the all over 2a part for the end, or 2 times 4. I like to write it all out and plug it all in. So when you're looking at that first step, you're just plugging in those coefficients, those key players, a, b, and c. A is with the squared, b is the linear term, it does not have an exponent, and c is your constant, the lonely number. So if we're using our calculator, we would do this whole thing in our calculator, just type it exactly like you see it. This is going to be a minus sign. And you can do this in your calculator and this, just step by step. These are a little bit easier for folks usually. So -1 times 2, -2. 2 times 4 is 8. And for this one, I'll show you how to type it in your calculator. So we'll go here and we'll do parentheses 2 squared, especially important when that is a negative to put it in parentheses. Minus 4. We're using our minus because it's outside of parentheses. Times 4, so parentheses, times -30. That's negative. So 484, you can kind of check that out. Make sure you plugged it in okay. 484 is positive, so that's how we know we're doing it right, because today we're going to get all positives or zeros. We're going to try to take the square root of 284. So I'm going to hit second x squared, 484. Such a big number, I don't know. Okay, perfect. If it came out a decimal, you would stop here. And this one didn't, so that works out for us. So this is 22. So we know x equals -2 plus or minus 22 over 8. And I'm going to work into number 4 just because I write really big. If you want to separate sheet of paper, you can. So the first one is -2 plus 22. We'll then divide that by 8, which is 20 over 8. You could reduce it or you could divide. So you could make it 10 over 4, 5 over 2. I don't want anyone to stress about reducing. So if you just want to divide it and make it a decimal, that's just fine. This one you'll subtract. So you'll have -24 over 8, which is -3. These problems might kind of look like a lot, but my key kind of factors or summary of this lesson is to set it equal to 0 by moving everything to the left where the n squared is positive or the whatever variable. If this is not positive, we'll talk about that in a second, but you can move everything to the right. I know we referenced that Beyonce song in our last video, everything in a box to the left. That really only works out nicely with factoring if this is positive. Since we're doing quadratic formula, you can still move everything to the left. So you kind of get to choose which way you want to move. Everything to the left might be more consistent for you and easier to remember. Then after you get your setup, you have A, B, and C. You want to make sure that A has the squared, the B has just the variable, and the C has a number. And then you can plug it in. Now, I'm not going to go through the whole problem solving on 5 and 6, but I want to make sure you know how to set them up. So for 5, when we add this 9 over, there is a like term that we can put it with. So we can drop down what we have, and then we can combine like terms. And we have our A, B, C. The part some people get confused on is We brought everything to the left and we have a negative here. Usually doesn't happen when we factor, but when we do quad formula, if it happens, just put yourself a little 1 there, a -1 since it's negative. And then you can plug those numbers in. The last thing I wanted to show, and I might actually go ahead and do this one, is number 6. When we bring this number over, there's no like term for it, but it is a constant. So if we look at our formula, constants go at the back. You might notice that the linear term is also missing, so there's no n. So we can carve out a space and put 0n plus 144 equals 0. My line is kind of confusing, so let me draw that again. I dropped that -4n squared down. I put a 0n because there's no linear term. And then that 144 becomes positive. So now we have A, B, and C, and we're going to plug that into our quadratic formula. So there's 2 key formulas we're using today. We're using graphing standard form, ABC, and quadratic formula. So x equals -1 times b plus or minus the square root of b squared minus 4 times a times c. It's all over 2 times a. So once again, this whole part can be done in our calculator. So we'll take it step by step. Good news about this problem is this actually anything times 0 cancels out. So that cancels. That's real nice. You just have to bring down your plus minus sign. And then whatever you get here, and then whatever you get here. So 2 times -4 is -8. You want to bring down a 0 and it makes your life easier, please feel free. We're going to do this part in our calculator. So we're going to do 0 squared minus 4 times -4. I have to keep looking. Square root 144. And we should get that. If you don't, just check that you're putting negatives inside the parentheses and minus outside. So 2304. We're going to see if that has a square root. And if it doesn't, we're going to stop here. So second x squared should come up like that. 2304. Look at that. It does have square root. It's 48. So that means we have plus or minus, we don't need the square root anymore, plus or minus 48 over -8. So that means we have a positive and a -48. If you wanted to put your 0, you could, but I just like to think of it as a positive 48 over 8, which is 6. I'm totally running out of paper. Hopefully you guys can squeeze this in. And then you have a -48 over -8. Which is also 6. So now we know that if we have something where we have to insert the 0, we will get the same answer for our root. So you only have to write that 6 once. The really neat thing about this one is we did a problem on our factoring video and we got the same answer when we put a 0 in the middle. So anytime you insert a 0, you will end up with the same answer. So that's how you can know that. Yeah, it's inserting a 0 in for the linear term. Perfect. Will you ever miss the quadratic term or the one with the squared? Not on these problems, no. If you were missing the constant, I'm not sure if that would arise for these particular problems, but always putting in a 0 if you're missing something from the ABC. Excellent questions, very good. There is a practice sheet on this, and as always, if you have additional questions, please let me know on how to use your calculator. You can always use PEMDAS instead, like we did in this original one, if that was better for you to kind of do what's under the radical with PEMDAS, that's fine as well. Just know that everybody solves their problems a little differently. Have a great rest of your day. Let me know if you have questions.